In this lesson, we're going to look at the graphs of the sine and cosine functions. So basically, this first page is just showing you how the sine and cosine curves are generated. So if we look at the unit circle, so remember the unit circle has a radius of 1. If we were to put in more angles, so basically all of these blue lines here representing our angles, if we were to put in more of these angles, this would allow us to figure out the sine of that angle, which is then graphed over here. So basically, if you remember sine, if you think about it in terms of right triangle trig, sine is equal to, so sine of an angle is equal to opposite over the hypotenuse, where if the hypotenuse is always going to be the radius of the circle, which is 1, so basically in this picture, sine of theta is equal to the opposite over the hypotenuse, which is always 1. So sine in this picture is always equal to the side opposite the angle. So that length represents sine of the angle. So when what we do over here is if we look, we have the first quadrant, second quadrant, third and fourth. Our markings, so this is 0 degrees. Then the split between the first and second quadrants, pi over 2, which is equivalent to thinking of it as like 90 degrees. Pi is like 180, and then 270, and then 360. So this gets us, this full sine curve is basically going around the unit circle. So the length at 0 degrees is at 0. But then when I move to the next angle here, see this little measurement here, so that's sine of whatever this angle is taken off of here and placed onto the graph. And then we take this next section, so sine of whatever this angle is equal to this length. So that gets replaced over here. So that angle measure would be here. So like let's say it was 45 degrees. So if this is a 45-degree angle, whatever this is would end up being 45 degrees here, and then the height is whatever this length is. So radical 2 over 2 would be the height for that. So same thing is these just keep getting replaced. So you can just see that as we move around the unit circle, whatever the opposite side is or whatever sine of that angle is, that gets replaced onto this graph. So that's really just showing you where the graph comes from. Now if you think of the next one, which is cosine, cosine's done the exact same way. The only difference is if you remember cosine, cosine's equal to the adjacent over the hypotenuse. So when we're looking at this unit circle, since the hypotenuse is always going to be 1 because that's the radius of this circle, if I'm looking at the adjacent over the hypotenuse, which is 1, that's really telling me that cosine of whatever the angle is really equal to the adjacent. So this time I'm looking at this pink piece or the adjacent piece as where these measurements are coming up for the points that create this cosine curve. So you can take all of these angles. So again, starting at 0, if you're starting at 0, the length of the adjacent is the radius of the circle. So that's why my cosine graph at x equaling 0, the y value is 1. And then we take another piece. So if I'm looking at this triangle, we're going to take this length, and that's going to get replaced. So depending on the angle, so if I'm looking at this triangle here, whatever this angle is, I'm going to be using this length to represent cosine of that angle. So we basically take the adjacents, we piece them together with their corresponding angle measures, and that is how we get this curve. And the reason why it's a curve is because there's infinitely many angles that you can find around here. So basically there's multiple heights that could be drawn, and then we would connect them and we get this curve shape. So some important points to note here is that we always are going to start at 0. We basically, our key points for both of these graphs are going to happen at the key points of the unit circle. So at 0, 90, 180, 270, and then again at 360. Same with this curve here. 0, 90 is a key point, 180, 270, and back to 360. We get our full cycle because it's the complete amount of degrees in a circle. So it's our complete um, around the circle, or a complete cycle around the circle. So that's why we have 360 degrees here to get our complete sine curve. Same thing with the cosine curve. So before we actually start looking at some other examples of graphs, let's look at some vocab so when we start talking about the graphs it makes sense. So I keep using this word cycle. Cycle of a graph is always the shortest repeating portion. So it's basically the unique part of the graph. So it's the shortest repeating portion. So it's what stands out. So when you look at your sine curve, this is one cycle because after this cycle here, it'll start to repeat. Same with this. This is one cycle. After this portion, it starts to repeat. The period for a graph is the horizontal length of one cycle. So how long is one cycle? So basically, for both sine and cosine, it takes 360 degrees or 2 pi to get a full cycle in. That's the length of one complete cycle. So the horizontal length of one cycle. And then when we talk about maximum minimum, this is the same as always when we're talking about max or min. These are the highest and lowest y values. So this is the largest y value, so the highest point. And then the minimum is the largest, or minimum is the smallest y value. And then the amplitude is going to be that distance that goes from the center to the maximum. So it's the vertical distance. Basically, it's like the height almost. So it's the vertical distance from the center to the maximum. So it tells us how high one of the peaks is. And then the last thing here is the frequencies. So the frequency is the number of cycles in a given interval. So it's however many cycles occur in a specific interval. So it's the number of cycles in a specific interval. And there's a formula for that. So if you want to find the frequency of a graph, basically what you do is you take 1 and you divide it by the period. That'll tell you the number of cycles in a specific period. So it's 1 cycle per whatever the period is. That's the frequency. So with that said, let's go ahead and actually look at the graphs. So let's sketch here the sine and cosine graphs just to refresh your memory of what those look like individually. So first thing I'm going to do is just draw on a set of axes. When I draw my axes, I'm going to kind of draw them off to the left here, since I want to start at 0. So this is going to be my x-axis, just like a normal graph, my y-axis. The difference here for the x-axis is we're going to do it in radians. Typically when you graph in radians. So what we're going to do is we're going to graph our key degrees or key points. So I'm going to do basically 0, 90, 180, 270, and 360, but I'm going to do them in radians. So I'm going to do every 4 here. 1, 2, 3, 4. I'm going to draw a hash mark. This will be pi over 2, just to spread this out more. 1, 2, 3, 4. This will be 180, so 90, 180, 270 will be next. So 1, 2, 3, 4. So this will be 3 pi over 2. And then 1, 2, 3, 4 will be my 2 pi or 360. And then, of course, 0 starting at the origin. So when we go to graph the line or the curve y equals sine of x, a couple of things to point out. The number in front of sine is 1. That's always going to be the amplitude. So this graph is going to have an amplitude of 1, meaning the peaks are going to go up to 1 or down to 1 or down to -1. And the period, so I'm just going to write these things and then we'll look at them for other graphs as well. So the amplitude is going to be 1. That's always going to be the number in front of sine. And then the period for sine and cosine curves are always going to be 2 pi unless there's some kind of number in front, and we'll talk about that in a little bit. So the period is 2 pi, meaning it takes 2 pi for one complete cycle to occur, or that's the length of one complete cycle. So another thing that I should add on here is that we know that since the amplitude is 1, the curve will reach up to +1, and it's going to reach down to -1. So I'm just going to add those markings in here. So we have -1 and 1. And I just did 4 units just so that I would be more spaced out. So now when I go to graph this, I know that sine of 0, so if I take sine of 0, I'm going to get 0. So we could go right from the unit circle is basically where I'm getting these points. So if I draw my unit circle, this is going to be 1, 0, 0, 1, -1, 0, 0, -1. So this is going to be 0 degrees, 90 degrees, 180, 270, and then 360. So remember, these translate to these markings here. 0, 90, 180, 270, 360. And if you remember, when we look at the unit circle, it's always cosine x, comma sine x. So when I'm looking for sine, I'm looking at all of the second values or all of the y values. So when I go to graph this, if I'm looking at sine of 0, which is the y value, I get 0. When I'm looking at sine of 90, I get 1. So this is going to go up to 1. Then I'm going to do sine of 180 is going to be 0. Sine of 270 is going to be -1. So at 270, I go down to -1. And then back up to 360 is going to be 0. So that's where this curve comes from. But remember, generally there'd be more points, but these are your basic points that you would want to plot if you were plotting a sine curve. And then let's look at y equals cosine of x. So again, the number in front of cosine is the amplitude, which in this case is 1. The period is going to be 2 pi. That'll always be the case because, again, it takes 2 pi for one cycle to occur, or the length of one cycle is 2 pi. So when I'm looking at cosine, I'm looking at the x values. So cosine of 0 is going to be 1. So I start up here at 1. When x equals 90, cosine is 0. When x equals 180, cosine of 180 is -1. Then I move down here, the x value is 0. And then I move up here, the x value is 1. So I come back up to 1. So here is the cosine curve. So this is going to be y equals cosine of x. So these are your basics. And they can keep going on because remember, we can keep going around the circle. And I could be going both ways around the circle. So I can get numbers bigger than 360. So these basically have arrows on them and the pattern will repeat because of all those coterminal angles. You can just keep going around the circle and you'll get these same points over and over again. And you're just adding 360 basically to these numbers. And you can also go the opposite way and get your negative angles. So these graphs go on forever. So the domain of these is going to be all real numbers. The range, though, is going to depend on whatever the amplitude is. So in this case, the standard cosine and sine functions have amplitudes of 1. So the maximums are going to be 1. The minimums are going to be -1, which tells me my range for both are between -1 and 1. So let's look at some other forms of sine and cosine so that you can see how different numbers in here change the amplitude in the period. So the next thing here is looking at a little bit more details with amplitude and period. So basically when you're looking at sine or cosine functions, you're going to see some number in front of sine and you're going to see some number in front of x. Same thing goes for cosine. So you're going to see a number in front of cosine, you're going to see a number in front of x. What these a's and b's stand for is a stands for the amplitude, and in order to find the amplitude, you're always going to take the absolute value of a because it's got to be a positive number. So that's the height of the curve basically. And then the period, how long one cycle is, you can find by taking 2 pi because that's the standard period for sine or cosine. It's also how long it takes to go around the unit circle. You're going to take that and you're going to divide it by whatever b is. And it's got to be by the absolute value because it's got to be a positive number. So those are your two formulas for this. And let's apply those to this example down here. So we want to graph y equals 3 cosine 4x. So now notice that there's two numbers involved. So the amplitude for this is going to be the absolute value of whatever the number in front of cosine is, which is 3. So the absolute value of 3 is 3. And then the period for this is going to be 2 pi over the absolute value of b, which is 4. So that means it's going to take 2 pi divided by 4, which if you reduce this, 2 over 4, 2 goes into 4 2 times, so it's really going to be pi over 2 if you reduce it. It's going to take one cycle will occur in pi over 2. So basically pi over 2 is 90 degrees. So one complete cosine graph will occur in 90 degrees. So it's really getting smaller because it's getting squished together because it only takes now pi over 2 for one cycle to occur instead of 2 pi. So that means the 4 stands for the frequency. There's 4 cycles that would occur in 2 pi is really what it's saying, because one cycle is occurring in a quarter of what we started with. So when we go to graph these, there's always 4 important points that we always plot. We always plot the 90, 180, 270, and 360. So we have to figure out what are the new important points. What are those new hash marks? So what you always do for this is whatever the period is, you're going to divide that by 4, and that'll tell you what your hash mark should be or what you should label your hash marks, because we always have to figure out those important points. So the formula for this is always just going to be take the period and divide it by 4, because there's 4 key points for both of these. So that means that the hash marks are going to be pi over 2 divided by 4. And if you remember, whenever we are dividing fractions, we're going to keep the first one. This is really like 4 over 1 at the bottom. And you're going to flip the second one. So you're going to have 1 over 4. So that means each hash mark should be pi over 8. Should be the units between them. So let's go ahead and let's start with this. So I'm going to start with my axes. And we have to go up to 3 this time because my amplitude's 3. So when I go to label my graph, what I'm going to do, start it off the same way, x and y. I'm just going to go up by 2's this time because you do want to spread this out, but you got to be able to fit it. So I'm going to go up to 3, and then I'm going to go down to -3. And then I can still go 4 across here. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, oops, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so remember this, according to this graph, one cosine curve is going to happen within pi over 2. So this last marking, instead of being 2 pi, is going to be pi over 2, because that's how long one cycle is going to occur. My points are going to be the exact same thing. When you start your cosine curve, it starts up at the highest point, which in this case is going to be 3. It then travels down here. It then goes all the way down to the lowest point, travels back up to 0, and then at that last point, it's coming back up to the maximum. So the shape of my graph is exactly the same thing. So this shape is exactly the same as what we just looked at on the previous page. The difference is my numbers, because the amplitude changed, and it's going to be down here is going to be different. So I first wanted to just graph that to show you that the shape is exactly the same, because basically, think about it on the unit circle, it's following that same pattern. So it's just these numbers are changing. So since my hash marks start at pi over 8, this one's going to be pi over 8, basically like 1/8 pi. Then we have plus pi over 8 to get to this next one. So what I'm going to do just to show you here, since it's fractions, the first one's always going to be 1 times whatever you get, so pi over 8. The second one, because the units between here has to be plus 1 over 8 pi, I'm just going to multiply it by 2. That'll get me my second hash mark. So if you cross that off, that becomes a 4. So pi over 4. So that's this one. The third hash mark, just multiply it by 3 because it's pi over 8 plus pi over 8 plus pi over 8. So pi over 8. So this is just going to be 3 pi over 8. And then the last one is 4 times pi over 8, which, cross that off, you get pi over 2. So that should always match the period. So that's how long it takes for one cycle to occur. So those are my markings. I should then just label this, and that will be it. Keep in mind that this graph will go on forever. It'll keep going on, but we're going to stop it here because I'm just going to graph one complete cycle. I can keep going, but I'm just going to end it with that. So let's just look at this last example just to show you what a sine curve looks like. So same idea with this one. Look at the numbers that we get. So we have 2 and we have 1/2. So the 2 is the amplitude. So that tells me that the highest and lowest points will go up 2 and then down to 2, down to -2. So the amplitude is 2. The period is going to be 2 pi divided by whatever b is, or the absolute value of b. So 1/2. So when you go to simplify this, keep the top and then change the bottom. So change the sign of multiplication, flip the bottom. This ends up giving us 4 pi. 4 pi and then over 1, which is just 4 pi. So that's how long it takes for one cycle to occur. So one cycle is going to occur after 4 pi. So that means this one is going to be twice the length as a normal sine curve, because a normal sine curve only takes 2 pi. This one's going to take twice that amount. So in order to figure out my hash marks for this, we do the same idea that we've been doing. So we do the period divided by 4, because you want to take this and you want to divide it up into its 4 key points. So the period divided by 4 means that you have 4 pi over 4, which means pi. So each key point happens after pi. So let's go ahead and draw our axes on to this. And we can label x and y. And the amplitude is 2, so this time I'm going to go up to 2. I went up by 3s this time just to space it out. This distance that you pick doesn't matter. I just like to space it out as much as possible. We still have 4 key points, so 1, 2, 3, 4. I'm just going to do, again, splitting it up by 4 to space it out. And then from here, we know that it's going to take pi for this entire thing, 4 pi for this entire thing to occur, because the period is 4 pi. And each hash mark occurs at pi, so increments of pi, because this distance is basically pi, because we took the 4 pi and we divided it up into 4 equal parts. So this happens within pi units. This happens if I take pi and I add another pi to it, I end up with 2 pi. And pi plus 2 pi equals 3 pi, because remember, this distance is like 1 pi between them. So you can think of it like this, same as the last time, but you just multiply it by whatever number the hash mark is. So the second hash mark times pi is 2 pi, third hash mark is 3 pi, and then the fourth hash mark should always match the period, which is 4 pi. So then getting the actual sine curve is exactly the same thing. So we start at 0, we move up to the highest point, go back down to 0, move down to the lowest point, and then we get back to 0. So that's your typical sine curve. Doesn't really matter what these are because it just is going around the circle, and it's telling you that a half a cycle occurs within 2 pi. So if you look at just the 2 pi portion, it's only half of the cycle, which is why this number is the frequency. It's telling you that a half occurs within 2 pi. And in order to get the full cycle, you got to graph to 4 pi. And I'm going to stop with that. I'm not going to continue it just because I just want to graph one complete cycle. Although, remember, these do keep going. The pattern would repeat.